So what we're going to look at next is how data is spread out and different ways that we can measure how things are spread out. Now, when we did our probability unit and we did the normal curve, we could figure out something was more spread out if it had a bigger standard deviation, and it was less spread out if it had a smaller standard deviation. In statistics, we look at, well, we've already looked at the median, but we're also going to look at what is the median of the lower half, and what is the median of the upper half. So we have things that are called quartiles. And so the median is your second quarter, which makes sense because it's halfway. So it's sometimes called the second quartile. So how far things are spread out is how far your quartiles are away from your middle. We already talked about the range being the difference from your smallest and largest values. And we'll also talk about the interquartile range. So that's the range between quartile 1 and quartile 3. And sometimes in data, you have something called an outlier that doesn't fit with the data. And here we find out that you can classify something as an outlier if it is 1.5 multiplied by whatever your interquartile range is, above or below your quartiles. Whew. It's too quick? Was that good? Got all? Yeah, okay. So here we have data. We want to find the range, the median, the quartiles, and the interquartile range for each of the following. Again, all of that data can be gotten from your calculator. If we wanted to do this by hand, we would first have to write them in order from smallest to biggest. So here we've got 3, 4, 5, 5, 6, 7, 7, 8, 9. We have 9 data points, so the middle one will be the 5th one. This will be your median. And your first quartile, well, now there's 4 values below and 4 values above. So your first quartile will split the lower half in half. So your first quartile will be 4.5. Your third quartile will be 7.5. Again, if we take that second bit of data, now we have an even number. We have 8 data pieces, so your median will be 12.5. And that splits your data into 2. We have 4 below that, so quartile 1 will equal 11. And quartile 3, halfway between 15 and 18, will be 16.5. For our first set of data, the interquartile range would be 3, because you go from 4.5 to 7.5. For our second bit of data, our interquartile range would be 5.5, because you go from 11 to 16.5. Is 25 an outlier? Well, if 25 is an outlier, since that's a large value, it would need to be more than 1.5 times the interquartile range above quartile 3. So if we do quartile 3, 16.5, and we add 1.5 times our interquartile range and figure out what value that would be, we get 24.75. So anything above 24.75 will be considered an outlier. So yes, 25 is an outlier. I put this because this is quartile 3. So to find out if something is an outlier because it's too big, you'd go quartile 3 plus 1.5 times interquartile range. If you were checking, let's say there was another data point here that was really small, like 1. And you're wondering, is 1 outside of my data? Then you would do quartile 1 minus 1.5 times your interquartile range. And anything lower than that would be an outlier. So an outlier is when something is 1.5 times the interquartile range, either above quadrant 3 or below quadrant 1. Notice in our data points that in our first one, we had a nice number for the median. And then for figuring out quartile 1 and quartile 3, that 6 doesn't get included. So now there's 4 below and 4 above. When we didn't have a nice number for our median, neither of those numbers are used up yet because your median's right between them. So there's 4 below and 4 above. If you wanted data, for example, if I added 1 on the bottom and 26 on the top, can you see that? Oh, I don't want to do that. Let's go to this one. This one, because it had a nice median. If I added 1 on the bottom and 26 on the top, the median would still be there, right? And now, quartile 3 would be a nice number. And quartile 1 would be a nice number. So if you want to find out what the position numbers of your quartiles are, remember I said you can find your median's position number by doing this, n plus 1 divided by 2, the number that you have. Your quartiles position number can be found by doing, well, this is quartile 1. Quartile 1. Quartile 1's position number would be n plus 1 divided by 4. And quartile 3 quartile 3's position number would just be 3 times quartile 1's. So when I added 2 more data points here, that gave me 11. 11 plus 1 divided by 4 is perfectly the third one. And then we had the third one as quartile 1. And the 9th one as quartile 3. And of course, again, we did this all by hand, but you can plug this all into your calculator to verify those results. So I would like you, on the next page, there are 2 more examples. I'd like you to do those 2 on your own and be prepared for next class, and we'll just quickly go over the results of those 2 to start next class.